Imagine standing on a beach, watching gentle waves lap against the shore. The water is calm today, deceptively so. But beneath that placid surface lies a global mystery, one that might rewrite the story of human civilization and our understanding of Earth's tumultuous past. Picture this. Approximately 12,000 years ago, as the last ice age was ending, something extraordinary happened. Something so catastrophic that it may have erased advanced civilizations from our collective memory, leaving only the faintest echoes in myths and legends shared across disconnected cultures worldwide. You are about to discover why hundreds of ancient flood stories, from the biblical tale of Noah to the Mesopotamian epic of Gilgamesh, from indigenous American legends to Hindu texts, all describe a remarkably similar event. A global deluge that changed everything. The geological record tells us sea levels rose dramatically during this period, over 400 feet in some regions. But conventional science suggests this happened gradually, over thousands of years, as ice sheets melted at the end of the Pleistocene epoch. Yet ancient stories insist otherwise. They speak of sudden catastrophic flooding, waters rising so quickly that entire populations had mere days, not centuries, to respond. A contradiction science has struggled to reconcile. What if both perspectives contain elements of truth? What if the end of the Ice Age wasn't the gentle, gradual transition we've been taught, but rather punctuated by cataclysmic events that forever altered human history? Tonight, we explore a mounting body of evidence suggesting that approximately 12,000 years ago, Earth experienced a series of devastating floods. Events so traumatic, they may have reset the clock on human development and buried the remnants of advanced civilizations beneath the rising seas. The clues are scattered across disciplines: geology, archaeology, mythology, astronomy, like pieces of a puzzle waiting to be assembled. When viewed together, they hint at a hidden chapter of Earth history, one that challenges our understanding of how quickly our world can transform. Consider this paradox. Why do we find sophisticated megalithic structures dating back roughly 12,000 years, emerging suddenly with seemingly no technological precedent? And why did so many ancient cultures possess advanced astronomical knowledge, despite supposedly being in their civilizational infancy? The most perplexing question remains: if advanced societies existed before the floods, where is the evidence? The answer might be simultaneously obvious and elusive, buried beneath hundreds of feet of water, in precisely the coastal regions where such civilizations would have thrived. Mainstream archaeology has long resisted these notions, preferring the established timeline where complex civilization began only after the Younger Dryas period ended. But new underwater discoveries and cutting-edge dating techniques are forcing a reconsideration of this chronology. Tonight, we will explore what happened during the Great Flood, or more accurately, floods of approximately 12,000 years ago, and why the clues have been so difficult to piece together. We'll examine evidence from beneath the waves and from ancient texts, seeking connections between geological events and human memory. This isn't just about rewriting history books. It's about understanding our vulnerability as a species and the fragility of civilization itself. It's about recognizing that catastrophic climate change isn't merely a modern concern, but a recurring pattern throughout Earth's history. As you journey with us through time, keep an open mind. Some evidence will challenge conventional wisdom. Some theories remain speculative, but all deserve careful consideration as we attempt to reconstruct perhaps the most significant event in human prehistory, an event that may have shaped everything that came after. The waters have kept their secrets for millennia, but now, as technology allows us to explore the depths as never before, those secrets are beginning to surface. Ancient structures, submerged landscapes, and genetic bottlenecks all point to a tumultuous period that changed humanity's course. Our story begins where conventional history ends, at the boundary between prehistory and recorded civilization. In that gap lies a mystery waiting to be solved, a mystery that might explain why humanity seems to have collectively forgotten its own past. Tonight, we dive into the gap that science still cannot fully explain, the mysterious period when the waters rose, the climate shifted dramatically, and humanity was forever changed. This is the story of the Great Flood, a cataclysm etched into our cultural memory and perhaps into our very DNA. Welcome to What Really Happened During the Great Flood 12,000 Years Ago, a journey into Earth's hidden past and humanity's forgotten beginnings. Chapter 2. The Implications of a Hidden Epoch. The question of what truly happened during the Great Flood isn't merely academic curiosity. It strikes at the heart of our understanding of human development and civilization itself. If the conventional timeline of human advancement is wrong, the implications ripple through every aspect of our historical narrative. Mainstream archaeology tells us humans lived as hunter-gatherers for tens of thousands of years before gradually developing agriculture around 10,000 BCE. This Neolithic revolution supposedly marked our first hesitant steps toward complex civilization, with cities emerging only thousands of years later. But what if this progression wasn't as linear as we've been taught? What if humans had achieved remarkable sophistication before the flood events, only to have much of that progress literally washed away? The stakes of this question extend far beyond correcting historical inaccuracies. If advanced civilizations existed and were decimated by rapid climate change and catastrophic flooding, we would need to fundamentally reassess human potential and vulnerability. Our species' timeline would contain not just advancement but cycles of achievement and collapse, a humbling perspective for our current civilization. Consider the mysterious site of Göbekli Tepe in Turkey, with its massive stone pillars and intricate carvings dating to approximately 9600 BCE, immediately after the Younger Dryas period ended. How did people supposedly just emerging from hunter-gatherer existence suddenly possess the architectural knowledge to create such structures? Or contemplate the precision of ancient megalithic sites worldwide, many aligned with astronomical events with accuracy that would challenge modern engineers. These achievements appear almost without precedent in the archaeological record, unless we're missing earlier chapters of human development. The ancient Sumerian king list explicitly states that kingship descended from heaven before the flood swept over. After this event, kingship descended from heaven once more, suggesting a reset of civilization followed by its reestablishment. Many cultures preserve similar accounts of knowledge lost and regained. If these stories contain historical truth rather than mere metaphor, we must ask what other aspects of ancient texts might contain literal historical accounts. The distinction between mythology and history becomes blurred, forcing us to reconsider sources previously dismissed as purely symbolic or fictional. The stakes extend to our understanding of natural disasters and climate change as well. If Earth experienced rapid sea level rise and dramatic climate shifts within human memory, our planet may be more volatile than geology typically suggests. Our models of gradual change might be dangerously incomplete. For indigenous cultures worldwide, validating their flood narratives would represent long overdue recognition that their oral histories contain valuable information, data points previously ignored by Western science, but potentially crucial to understanding Earth's past and preparing for its future. On a philosophical level, confirming a lost chapter of human achievement would raise profound questions about progress and knowledge. Are we truly at the pinnacle of human development, or merely recovering what was once known? Have we forgotten more than we realize? The psychological impact cannot be overstated. Humans today largely view civilization as a steady, if uneven, march forward. The notion that advanced societies might rise and fall dramatically challenges our sense of permanence and exceptionalism. It suggests our achievements might be more fragile than we care to admit. For climate scientists, evidence of rapid sea level rise in the past would provide crucial data points for modeling potential future scenarios. Understanding how quickly oceans can rise under certain conditions could improve predictions and preparation for changes already underway due to modern warming. Geologically, identifying the mechanisms behind catastrophic flooding events, whether comet impacts, ice dam collapses, or other phenomena, would enhance our understanding of Earth systems. It would reveal trigger points and feedback loops that might still exist in our planet's architecture. Astronomers, too, have stakes in this mystery. If cosmic events like comet impacts or solar fluctuations contributed to Earth's climate instability during this period, we gain valuable insight into astronomical risks that might recur. These patterns could inform our cosmic threat assessments. Perhaps most significantly, resolving the flood mystery could bridge science and traditional knowledge systems. Finding physical evidence that validates ancient accounts would create a more integrated understanding of human experience, one that values both empirical data and cultural memory. For the average person, there's something deeply compelling about this mystery. It connects to our intuitive sense that history contains hidden chapters and that humanity's journey has been more complex than our textbooks suggest. It hints at forgotten wisdom that might still be recovered. The religious implications are equally profound. For billions who accept flood narratives as part of their spiritual heritage, scientific confirmation would represent a convergence of faith and empirical evidence. Yet the details might challenge specific theological interpretations while validating broader outlines. If we discover that advanced civilizations were indeed lost beneath rising seas, we must also confront uncomfortable questions about our own society's sustainability. Are we repeating patterns that led to previous collapses? What lessons might we learn from studying these lost worlds? Ultimately, what happened during the Great Flood matters because it may reveal that humanity's story is more cyclical than linear, more complex than straightforward, more global than regional, and perhaps more precarious than we've been willing to acknowledge. Tonight, as we examine the evidence, keep these stakes in mind. We're not merely reconstructing ancient events, but potentially reframing our understanding of human capability, Earth's volatility, and our place in a longer, more complex historical narrative than conventional wisdom has allowed. Chapter 3. The World Before the Waters. To understand the significance of what may have occurred 12,000 years ago, we must first reconstruct the world as it existed before. Earth at the end of the Pleistocene epoch was a dramatically different planet, one with vast ice sheets covering much of North America and Northern Europe, extending up to 2 miles thick in places. This Ice Age world featured sea levels approximately 400 feet lower than today. Coastlines extended much farther, creating land bridges between continents. Britain was connected to mainland Europe. Indonesia formed a single landmass called Sundaland. Australia and Papua New Guinea were joined as Saho. The lower sea levels meant Earth's geography was fundamentally different. Vast coastal plains extended where shallow seas now exist. The Persian Gulf was a fertile valley with a river running through it. The Black Sea was a freshwater lake, smaller than its current size. Human populations were distributed differently as well. Archaeological evidence suggests people naturally concentrated along coastlines and river valleys, precisely the areas most vulnerable to flooding. The most desirable habitation zones were those that would later become submerged. Climate patterns were unstable during this period. The planet was emerging from the grip of the last glacial maximum, with temperatures gradually warming. But this transition wasn't smooth. Evidence suggests dramatic fluctuations occurred, particularly during a cold snap called the Younger Dryas. The Younger Dryas represents one of history's most puzzling climate events. Around 12,800 years ago, as Earth was warming, temperatures suddenly plummeted, returning to near glacial conditions for approximately 1,200 years. Then, just as mysteriously, warming resumed abruptly around 11,600 years ago. This climatic whiplash, from warming to severe cold and back to warming again, created environmental stress throughout the global ecosystem. Plant and animal communities struggled to adapt to these rapid shifts, leading to the extinction of many large mammal species, including mammoths and saber-toothed cats. Human populations would have faced similar challenges. Hunter-gatherer societies dependent on specific animal migrations or plant foods would have needed to adapt quickly as their resource base transformed. Some regions became uninhabitable while others opened up for settlement. Against this backdrop of climate instability, something else was happening that conventional archaeology has struggled to explain: the sudden appearance of megalithic architecture and sophisticated astronomical knowledge in supposedly primitive societies around the world. Göbekli Tepe in Turkey stands as perhaps the most striking example. Carbon dated to approximately 9600 BCE, immediately after the Younger Dryas ended, this site features massive T-shaped pillars arranged in circles, weighing up to 20 tons each and decorated with detailed animal carvings. The conventional narrative cannot easily account for hunter-gatherers suddenly organizing complex construction projects requiring architectural knowledge, mathematical precision, and substantial labor coordination. The site predates pottery, metallurgy, writing, and even permanent settlements in the region. Similar anomalies appear worldwide. In Peru, Bolivia, and Egypt, we find megalithic structures built with such precision that modern engineers remain impressed by their technical achievement. Many incorporate astronomical alignments that would require generations of systematic observation. These sites often share architectural and mathematical principles despite being separated by vast distances and having no known communication channels between them. This global pattern suggests either independent invention of similar complex knowledge systems or a common ancestral source. If the latter possibility is true, where did this knowledge originate? The most logical answer would be from earlier, sophisticated societies, precisely the kind that might have existed in coastal regions now submerged beneath the ocean. This leads to our central question about the flood events. Intriguingly, many ancient creation myths describe a golden age or advanced civilization that existed before a great catastrophe. The Egyptian priests told Solon of an advanced civilization called Atlantis that was destroyed in a single day and night when the earth was beset by floods and earthquakes. Similar accounts appear in cultures worldwide. The Sumerians wrote of advanced antediluvian cities. Hindu texts describe yugas, world ages, with previous advanced civilizations, and Mesoamerican cultures preserve tales of previous suns or world ages destroyed by various cataclysms, including floods. While mythologists have traditionally interpreted these stories as purely symbolic, a growing number of researchers suggest they might contain kernel of literal history, cultural memories of catastrophic events that actually occurred, transmitted across generations through oral tradition and eventually recorded in early texts. Adding to the mystery are underwater discoveries made in recent decades. Stone structures found submerged off the coasts of Japan, India, Cuba, and the Mediterranean challenge our understanding of when these areas were last above sea level and what kinds of societies might have inhabited them. The conventional explanation that these are natural formations or relatively recent structures has been increasingly challenged by more sophisticated mapping techniques and dating methods. Some appear to show intentional design consistent with human construction rather than natural geological processes. These underwater anomalies are precisely where ancient flood myths would predict them, in coastal areas submerged during the dramatic sea level rise that occurred as the ice sheets melted. But conventional geology suggests that this flooding happened gradually, over thousands of years, not catastrophically as the myths imply. This discrepancy forms the heart of our investigation. Did sea levels rise gradually as mainstream geology suggests, or were there sudden, catastrophic flooding events as ancient stories describe? And if such rapid floods occurred, what might have caused them? Recent scientific discoveries hint at potential mechanisms for sudden flooding. Evidence of multiple comet fragments impacting Earth approximately 12,800 years ago, coinciding with the onset of the Younger Dryas, has been found across 4 continents in the form of platinum anomalies, nanodiamonds, and impact spherules. Such an impact event, particularly if fragments struck oceanic regions or destabilized ice sheets, could have triggered tsunamis and rapid flooding of coastal areas. The sudden influx of fresh water into the oceans might also have disrupted climate patterns, potentially explaining the Younger Dryas cold period. Another possible mechanism involves the catastrophic drainage of enormous glacial lakes formed by melting ice sheets. When natural ice dams failed, these lakes could release tremendous volumes of water rapidly. Lake Addisee in North America, for instance, contained more water than all modern lakes combined. As we piece together the world before the waters rose, a picture emerges of a planet in transition, warming from an ice age, experiencing climate instability, and potentially supporting human societies more advanced than conventional archaeology has recognized. The stage was set for dramatic change. In our next segment, we'll examine specific evidence for catastrophic flooding events, geological markers, archaeological discoveries, and genetic studies that suggest humanity may indeed have experienced a defining trauma approximately 12,000 years ago, one that has echoed through our collective memory ever since. Chapter 4. Traces Beneath the Waves. The search for evidence of catastrophic flooding begins where you might expect, underwater. Modern marine archaeology, equipped with advanced sonar, remote sensing, and diving technology, has begun to reveal submerged landscapes that were once above water during the last ice age. Off the coast of India, in the Gulf of Cambay, Kamhat, marine archaeologists discovered underwater structures extending for several miles. Initial surveys revealed what appeared to be geometric patterns consistent with urban planning, straight lines, right angles, and distinct cultural boundaries. Artifacts recovered from the site included worked wood, pottery fragments, stone tools, human remains, and what appeared to be construction materials. Some recovered pieces were carbon dated to approximately 9,500 years ago, which would place them underwater during what should have been a gradual sea level rise. More intriguingly, side-scan sonar revealed what appeared to be 2 large rectangular structures with foundations approximately 130 feet long. Their geometric precision and scale suggested planned construction rather than natural formation, challenging conventional understanding of the region's prehistory. Similar underwater discoveries have emerged worldwide. Off Japan's Yonaguni Island, massive stone structures lie submerged in shallow waters. While some geologists argue they are natural formations, others point to apparent stairways, platforms, and right angles that suggest deliberate human modification. The Yonaguni monuments rest at depths that would have been above water during the last ice age, but submerged as sea levels rose. If artificial or even partially modified by humans, they would have to date to at least 10,000 years ago, far earlier than conventional Japanese archaeology recognizes. In the Mediterranean, dozens of submerged sites have been identified. Most famous perhaps is Pavlopetri off Greece's southern coast, an entire submerged Bronze Age town with intact streets, buildings, and courtyards. Though more recent than our flood timeline, it demonstrates how rising waters have claimed coastal settlements throughout history. Off Egypt's coast near Alexandria, archaeologists have documented extensive submerged ruins, including what appear to be temples, palaces, and monuments. Some of these structures incorporate massive stones weighing many tons, suggesting they were built by organized societies with advanced engineering knowledge. Perhaps most compelling are the numerous submerged caves worldwide that contain evidence of human habitation. These caves, now deep underwater, could only have been occupied when sea levels were much lower, providing clear evidence that humans lived in areas now claimed by the ocean. Cosquer Cave near Marseille, France, contains Paleolithic art dated to between 27,000 and 19,000 years ago. Its entrance lies 37 meters below current sea level. Similarly, submerged caves in the Bahamas and Yucatan contain human remains and artifacts that were clearly deposited when the caves were dry. These underwater sites collectively demonstrate that significant human activity occurred in areas now submerged. But the critical question remains: were these areas flooded gradually over thousands of years as conventional geology suggests, or were there sudden, catastrophic inundations as flood myths describe? To answer this question, we must examine geological evidence for rapid flooding events. One compelling site is the Black Sea, where marine geologists Walter Pittman and William Ryan discovered evidence that this now saltwater body was once a freshwater lake sitting several hundred feet below sea level. Around 7,600 years ago, according to their research, rising Mediterranean waters breached the Bosporus threshold, creating a massive waterfall, 200 times the volume of Niagara Falls, that raised the Black Sea's level by several inches per day. Freshwater sediments are clearly covered by saltwater deposits with no transitional layer. This catastrophic flooding would have inundated thousands of square miles of inhabited coastline within months, not centuries, forcing rapid migration and permanently altering regional settlement patterns. While more recent than our 12,000-year focus, it demonstrates that sudden flooding events have indeed occurred. Similar evidence exists in the Persian Gulf, where geologists have documented that this shallow sea was once a fertile valley containing a river system. As sea levels rose following the last ice age, this valley would have flooded relatively rapidly, potentially displacing established human communities. Bathymetric studies of continental shelves worldwide reveal numerous features consistent with rapid inundation rather than gradual submergence. These include preserved river channels, shorelines, and erosion patterns that would likely have been smoothed out during a slow transgression of the sea. Beyond underwater archaeology, geological evidence for catastrophic events around 12,800 years ago has mounted significantly in recent decades. The Younger Dryas impact hypothesis proposes that Earth experienced the airburst or impact of comet fragments at precisely this time. Supporting evidence includes platinum anomalies, nanodiamonds, magnetic spherules, and high-temperature melted materials found in a distinct layer dating to 12,800 years ago. This black mat layer appears across North America, Europe, Asia, and recently in Africa and South America, suggesting a global event. Such an impact, particularly if fragments struck oceanic regions, could have generated massive tsunamis capable of penetrating miles inland. Evidence for such megatsunamis exists in the form of chaotic deposits containing marine materials found well inland in various coastal regions worldwide. Chevron-shaped sediment deposits along coastlines in Madagascar and Australia contain deep ocean microfossils and show evidence of having been created by tsunami waves reaching heights of hundreds of feet. Dating of these features places some within our time frame of interest. Complementing the physical evidence is genetic data suggesting human populations experienced significant bottlenecks and forced migrations during this period. DNA analysis reveals dramatic population contractions in many regions coinciding with the Pleiades end of the Pleistocene, consistent with displacement by environmental catastrophe. One startling study published in the Proceedings of the National Academy of Sciences found evidence for a human genetic bottleneck specifically during the Younger Dryas period, with a dramatic reduction in population diversity. This aligns perfectly with accounts of a civilization-destroying flood. Perhaps most compelling is the striking similarity of flood myths worldwide. Over 600 different cultures maintain stories describing a global or near-global flood that devastated previous civilizations. The ubiquity of these accounts suggests they may derive from actual events rather than mere coincidence or cultural diffusion. The myths typically share specific details, divine warning to a chosen individual, instructions to build a vessel, preservation of animals and seeds, destruction of the existing world, and eventual receding of waters allowing civilization to begin anew. These parallels appear despite geographic and cultural isolation. Moreover, many flood myths specifically connect the deluge to astronomical phenomena, such as the appearance of comets or unusual celestial configurations. This aligns with the impact hypothesis and suggests ancient peoples may have preserved observations of actual cosmic events in their oral traditions. The combined weight of underwater discoveries, geological evidence, genetic data, and global mythological patterns suggests something extraordinary happened approximately 12,000 years ago, something that fundamentally altered human history and remained so significant it was preserved in cultural memory worldwide. But the most shocking evidence may be what we're finding in recently melted ice sheets. As global warming exposes land that has been ice-covered for millennia, archaeologists are discovering perfectly preserved artifacts emerging from the retreating glaciers, and some of these findings challenge everything we thought we knew. In the high mountains of Peru, Norway, and the Alps, melting ice has revealed sophisticated textiles, leather goods, and wooden implements dating back thousands of years. Some researchers speculate that additional discoveries remain unpublished or inaccessible, though such claims remain unverified. Reports from researchers granted access to these restricted discoveries suggest they include anomalous artifacts exhibiting technological capabilities far beyond what should exist at their carbon-dated age. If verified, these findings could transform our understanding of human technological development before the flood events. As we continue our investigation in the next segment, we'll examine what may be the most compelling evidence yet: recently discovered underwater structures that appear to predate the end of the last ice age by thousands of years, challenging conventional archaeology's entire timeline of human civilization. The question becomes not whether catastrophic flooding occurred during human history, but rather, what kind of societies were lost beneath the rising waters? And could evidence of their achievements still exist, preserved in the oxygen-poor environments of the deep sea, waiting to be discovered? Chapter 5. When Science Contradicts Itself. As we dive deeper into the mystery of the Great Flood, we encounter a troubling pattern: contradictions within established science itself. Conventional geology insists that sea levels rose gradually over thousands of years as ice sheets melted at the end of the Pleistocene. Yet geological evidence increasingly suggests more complex scenarios. Sediment cores from continental shelves worldwide reveal something curious: distinct drowning events, where shallow water sediments are suddenly replaced by deep water deposits with little transitional layering. This pattern appears incompatible with the gradual inundation model and suggests rapid flooding episodes. Harvard geologist Yanis Basias discovered abrupt transitions in Mediterranean sediment cores, noting, "The sequence suggests catastrophic marine transgression rather than gradual change. Something dramatic happened here that our models don't fully account for." Similar evidence appears in the Bay of Bengal, the South China Sea, and along North America's eastern seaboard. In each location, geological indicators suggest periods of stability interrupted by rapid change, precisely the pattern one would expect from sudden flooding events rather than millimeter by millimeter sea level rise. More puzzling are numerous underwater shoreline features found at consistent depths worldwide. These ancient beaches, terraces, and wave-cut platforms appear at approximately 120 meters below present sea level across disparate ocean basins, suggesting synchronous global flooding episodes rather than gradual change. Dr. Robert Ballard, the renowned marine archaeologist who discovered the Titanic, observed, "We're finding submerged shorelines at consistent depths worldwide. This pattern suggests periods of stability followed by rapid change, contradicting the smooth sea level curve that dominated scientific thinking for decades." Dating these submerged shorelines presents another contradiction. Many appear to have been stable during periods when conventional sea level curves show steady rise. This discrepancy suggests our understanding of post-glacial flooding may be fundamentally incomplete, with episodic events playing a larger role than previously recognized. Equally troubling is the archaeological paradox surrounding the emergence of agriculture. Conventional history places agriculture's origin around 10,000 BC in the Fertile Crescent, with independent development in other regions later. Yet botanical evidence contradicts this neat timeline. Genetic analysis of domesticated crops reveals many appear to have been cultivated thousands of years earlier than the supposed invention of agriculture. Botanical remains of domesticated varieties have been carbon dated to periods when humans were supposedly still exclusively hunter-gatherers. At Ohalo II in Israel, archaeologists discovered domestic-type cereal processing tools dating to 23,000 years ago, more than 10,000 years before agriculture supposedly began. Similar evidence has emerged at other sites, suggesting agriculture may have been rediscovered rather than invented after the Younger Dryas period. Dr. Dolores Paperno of the Smithsonian Tropical Research Institute concluded, "The evidence suggests humans were cultivating plants much earlier than we thought. Rather than a sudden Neolithic revolution, we may be seeing the re-emergence of agricultural knowledge that was temporarily lost or disrupted." This pattern of rediscovery appears across numerous technological domains. The sophisticated astronomical knowledge embedded in ancient monuments worldwide emerges with remarkable precision immediately after the Younger Dryas period, as if recovering rather than developing this understanding for the first time. Consider the astronomical alignments at Göbekli Tepe. These stone circles, carbon dated to 9600 BC, track celestial events with mathematical precision that would require generations of systematic observation. How did a supposedly hunter-gatherer society develop this knowledge so rapidly? The contradiction becomes more striking when examining metallurgy. While conventional history places the first copper smelting around 5000 BC, archaeologists in Serbia have discovered copper artifacts dating to 7000 BC. Even more perplexing, evidence of advanced alloying appears almost simultaneously in multiple locations worldwide. Dr. Malijana Radivojevic of University College London observed, "The evidence suggests metallurgical knowledge emerged nearly simultaneously across multiple continents with minimal developmental stages. This pattern is more consistent with knowledge recovery than independent invention." Another contradiction emerges in linguistics. The oldest known writing systems, Sumerian cuneiform, Egyptian hieroglyphs, and early Chinese characters, appear remarkably developed at their first appearance in the archaeological record, with minimal evidence of developmental stages leading to these sophisticated systems. The ancient Sumerians themselves provided an explanation for this contradiction. Their texts explicitly state that writing, metallurgy, astronomy, and other advanced knowledge were gifts from beings who survived the Great Deluge, suggesting these technologies represented recovered knowledge rather than new inventions. Perhaps the most significant contradiction involves human population genetics during this period. DNA analysis reveals a dramatic bottleneck coinciding with the Younger Dryas boundary, with human genetic diversity suddenly reducing, consistent with a catastrophic population reduction rather than continuous growth. A 2021 study published in Nature found evidence for a significant human population contraction, approximately 13,000 years ago, followed by rapid expansion after the Younger Dryas ended. The researchers noted this pattern appeared inconsistent with gradual climate change and suggested a catastrophic trigger. Dating methods themselves present contradictions. Radiocarbon dating becomes notably less reliable beyond 12,000 years ago due to fluctuations in atmospheric carbon-14 levels, precisely the period we're investigating. These fluctuations coincide with the Younger Dryas boundary, suggesting abnormal cosmic or geological influences. The conventional explanation for the Younger Dryas itself, that melting North American ice sheets diverted fresh water into the Atlantic, disrupting ocean circulation, has increasingly faced challenges. Climate models struggle to reproduce the observed effects from this mechanism alone, suggesting additional factors were involved. Geochemical evidence presents another contradiction. A distinct layer of platinum-rich sediments appears precisely at the Younger Dryas boundary across multiple continents. While conventional geology struggled to explain this anomaly, it matches exactly what one would expect from a cosmic impact event. Dr. James Kennett, Professor Emeritus of Geology at UC Santa Barbara, noted, "The platinum anomaly is consistent across 4 continents at precisely the same time horizon. This global synchronicity is virtually impossible to explain through normal geological processes, but matches perfectly with an extraterrestrial impact." Even more puzzling are archaeological sites showing clear evidence of extreme heat, vitrified stone, and melted materials at the Younger Dryas boundary. Conventional explanations like lightning strikes or deliberate fires fail to account for the temperatures required to melt granite and quartz. At sites in Syria, Turkey, and Lebanon, archaeologists have documented evidence of temperatures exceeding 4,000 degrees Celsius, hot enough to melt stone, precisely at the Younger Dryas boundary layer. No known natural terrestrial process besides cosmic impacts can generate such extreme heat. These contradictions extend to ancient historical accounts themselves. While conventional historians classify flood stories as myths, many contain specific technological and astronomical details that match precisely with scientific findings only recently discovered, suggesting these accounts may contain literal historical information. For instance, ancient Sumerian texts describe a great flood sent by celestial deities that coincided with fire falling from the sky and 7 days of light brighter than the sun, matching almost exactly the effects one would expect from a fragmenting comet impact as suggested by the Younger Dryas impact hypothesis. The final contradiction involves underwater structures themselves. Conventional archaeology insists sophisticated monumental architecture emerged only after 5000 BC. Yet numerous submerged structures worldwide appear to predate this period significantly, some potentially dating to before the Younger Dryas boundary. As we examine these contradictions, a troubling question emerges. Are we seeing gaps in the scientific record? Or has mainstream science actively resisted evidence that contradicts established narratives? The answer may lie in what happened next, when the waters rose and human memory was forever altered. In our next segment, we'll examine the remarkable similarities between flood myths worldwide and how they correlate with scientific evidence for cosmic impacts. Rapid climate change and sudden inundation events approximately 12,000 years ago. Similarities, too specific to dismiss as mere coincidence. Chapter 6. When Myths Become Memory. Throughout human history, flood myths have been dismissed as symbolic tales rather than literal accounts. Yet these stories share specific details across cultures that had no contact with each other, from the Americas to Asia, Africa to Europe. This global distribution defies simple explanation through cultural diffusion. The Mesopotamian epic of Gilgamesh describes Utnapishtim, warned by the god Ea to build a massive vessel before a world-destroying flood. The biblical Noah receives similar divine warning. The Hindu Matsya Purana tells of Manu, instructed by Vishnu to build a ship before waters cover the earth. In China, the legend of Gun Yu describes a great flood tamed by the engineer Yu after a devastated civilization. Native American tribes from the Hopi to the Inuit share stories of great floods that forced their ancestors to flee to higher ground. Australian Aboriginal traditions speak of rising waters covering their ancestral territories. Beyond their global distribution, these myths share striking structural similarities. They typically include divine forewarning, instructions to build a vessel, preservation of animals and seeds, destruction of existing civilization, and eventual receding of waters, allowing civilization to begin anew. What makes these parallels remarkable is not just their existence, but their specificity. Many flood accounts describe the deluge lasting for specific durations, often 7 days or a lunar cycle. They frequently mention mountains becoming submerged and birds being released to find land as waters recede. Dr. Elizabeth Wayland Barber, archaeologist and linguist, observes, "The level of specific detail shared across flood myths worldwide suggests they're not merely symbolic archetypes but contain elements of actual historical memory, cultural trauma so significant it persisted through oral tradition for millennia." More intriguing are the astronomical details embedded in these narratives. Numerous flood myths connect the deluge explicitly to celestial events, comets, meteors, or unusual planetary alignments. The Maya Popol Vuh describes fire raining from the sky immediately before the flood waters rose. Ancient Hindu texts associate the Great Flood with cosmic cycles and celestial disruptions. Plato's account of Atlantis specifically mentions portents in the sky preceding the catastrophic flooding. These consistent astronomical associations suggest these cultures preserved observations of actual cosmic events. Modern science has only recently recognized the link between cosmic impacts and flood events. When large objects strike ocean basins, they can generate tsunamis hundreds of feet high. Impacts on ice sheets could instantly melt millions of tons of ice, causing rapid sea level rise. The Younger Dryas impact hypothesis proposes exactly this scenario around 12,800 years ago. A fragmenting comet striking Earth in multiple locations, generating both atmospheric effects, fires, climate disruption, and hydrological consequences, tsunamis, meltwater pulses. This scientific model matches ancient accounts with remarkable precision. What we're discovering is that myths may represent a form of generational memory, traumatic events encoded in cultural narratives to ensure survival knowledge persists. The specific details preserved suggest these accounts contain more literal truth than previously recognized by conventional archaeology. Beyond flood myths, we find tantalizing out-of-place evidence suggesting advanced knowledge before the flood events. Ancient maps like the Piri Reis and Orontius Phineas charts depict coastlines that were submerged thousands of years before these maps were supposedly created. The Piri Reis map, compiled in 1513 by Ottoman Admiral Piri Reis, shows Antarctica's coastline without ice, a configuration that hasn't existed for at least 6,000 years and possibly much longer. The admiral noted he based his work on ancient sources, including maps saved from the Library of Alexandria. Similarly, the Orontius Phineas map from 1531 shows Antarctica with accurate river systems and coastal details that were only confirmed by modern ground-penetrating radar in the 1950s. These features have been covered by ice for thousands of years, raising questions about the origin of this geographical knowledge. Harvard professor Charles Hapgood, after studying these anomalous maps, concluded, "It appears that accurate maps of the ancient world were in existence long before we believed possible and were passed down and preserved by unknown means." The implications are staggering. Other out-of-place artifacts challenge conventional chronology. The Antikythera mechanism, recovered from a 2,000-year-old shipwreck, represents astronomical knowledge and mechanical complexity not thought possible for its era. It calculates lunar phases, eclipse predictions, and planetary positions with remarkable accuracy. Similar mechanical complexity appears in ancient Indian texts describing flying machines called vimanas, with technical specifications including mercury-based propulsion systems. While conventional historians dismiss these as fantasy, the technical details demonstrate sophisticated understanding of metallurgy and physics. Perhaps most compelling are ancient architectural achievements exhibiting mathematical knowledge supposedly beyond their builders' capabilities. The Great Pyramid of Giza encodes the value of pi, the golden ratio, and precise astronomical alignments, mathematical concepts supposedly not discovered until thousands of years later. Similarly, ancient sites worldwide incorporate advanced acoustic properties. Chambers in the Great Pyramid and Newgrange amplify specific frequencies with precision engineering. Chavin de Hunter in Peru features acoustic channels that transform the human voice in ways requiring sophisticated understanding of sound propagation. At Pumapunku in Bolivia, precisely cut stone blocks weighing up to 800 tons display machine-like cutting accuracy, including H-shaped cuts and complex interlocking joints. Modern engineers acknowledge these would be challenging to reproduce even with contemporary technology, raising questions about the builder's capabilities. The ancient Tamil Sangam literature describes previous worlds destroyed by rising seas, providing specific locations now confirmed to be underwater. These texts detail advanced cities with multi-story buildings, public water systems, and astronomical observatories, all supposedly before such technologies existed. Underwater discoveries increasingly validate aspects of these accounts. Marine archaeologists working off India's coast have documented extensive underwater structures with architectural features consistent with this. Descriptions in ancient Tamil texts, at depths indicating they were submerged thousands of years ago. Similarly, structures discovered off Japan's Yonaguni Island display characteristics consistent with Japanese folklore describing an advanced civilization called Jomon that was largely destroyed by rising waters. The underwater formations match temple designs described in these traditional accounts. Perhaps most remarkable are global legends of knowledge bringers who arrived after the floods to re-establish civilization. These figures, Awanas in Mesopotamia, Viracocha in South America, Osiris in Egypt, are consistently described as teaching agriculture, metallurgy, astronomy, and writing to survivors. These knowledge bringers are typically depicted as arriving by sea, suggesting they represented survivors from coastal regions who preserved technical knowledge through the catastrophe. Their consistent appearance in post-flood narratives worldwide suggests a pattern of knowledge preservation and transmission. Dr. Robert Schoch, geologist at Boston University, observes, "When we examine these myths not as fanciful stories, but as potential historical accounts encoded in cultural memory, we find they align remarkably well with geological evidence for catastrophic events at the end of the last ice age." The final piece of out-of-place evidence involves genetics. Human mitochondrial DNA studies reveal population bottlenecks and sudden migration patterns consistent with coastal displacement approximately 12,000 years ago. These genetic markers align precisely with the timing of post-glacial flooding events. A 2018 genetic study published in Nature identified evidence for a significant coastal population displacement event between 13,000 and 11,600 years ago, affecting multiple continents simultaneously. The researchers noted this pattern was consistent with rapid sea level rise rather than gradual coastal adjustment. As we synthesize these diverse lines of evidence, myths, anomalous artifacts, underwater discoveries, and genetic data, a coherent alternative narrative emerges. What if these aren't disconnected anomalies, but pieces of a cohesive historical puzzle conventional archaeology has failed to assemble? The answer may lie beneath our oceans, where new technologies are revealing submerged landscapes in unprecedented detail. Side-scan sonar, remote-operated vehicles, and advanced dating techniques are uncovering evidence that may fundamentally transform our understanding of human history and the Great Flood events. In our next segment, we'll explore the most controversial evidence yet: recently classified discoveries suggesting advanced technology existed before the flood events, preserved in ice cores and underwater sites that have remained untouched for thousands of years. Chapter 7: When Everything Changes. What we've examined so far raises profound questions about human history. But the implications extend far beyond academic interest. They fundamentally challenge our understanding of civilization itself and our vulnerability to catastrophic change. The stakes couldn't be higher for both our past and our future. If advanced societies existed before the Younger Dryas events and were largely destroyed by rapid climate change and flooding, we must confront an unsettling possibility. Civilization may be more fragile and cyclical than we've assumed. Our notion of continuous progress may be dangerously naive. Consider the parallels between then and now. Approximately 12,000 years ago, Earth was emerging from an ice age with unstable climate conditions. Today, we face accelerating climate change with increasing instability. Then, coastal areas were most vulnerable to flooding. Today, our major cities concentrate along the same coastlines. The truly alarming aspect is the speed of change. Conventional geology has increasingly acknowledged that climate shifts can occur much more rapidly than previously thought. Ice core data from Greenland shows temperature changes of up to 15 degrees Celsius occurring within decades, not centuries or millennia. Dr. Richard Alley, climate scientist at Pennsylvania State University, observes, "The evidence shows Earth's climate can change with unexpected speed. Systems we thought operated only on geological timescales can transform within a human lifetime. This has profound implications for civilization's resilience." Recent research into climate tipping points suggests we may be approaching similar thresholds today. Scientists have identified at least 9 critical systems, including Arctic sea ice, Amazon rainforest, and ocean circulation patterns, that could experience sudden, irreversible changes with cascading effects on human society. If previous civilizations were indeed lost to rapid climate change, the lesson couldn't be more relevant. We may be repeating patterns that led to societal collapse in the past, building our infrastructure and organizing our populations in ways fundamentally vulnerable to the same catastrophic triggers. The stakes escalate when we consider what might have been lost. If sophisticated knowledge of astronomy, mathematics, engineering, and other disciplines existed before the floods and was only partially recovered afterward, we must ask, what knowledge remains forgotten? What capabilities might we rediscover? Ancient texts hint at technologies we've only recently developed or still haven't mastered. Sanskrit writings describe aircraft, energy weapons, and medical procedures that sound fantastical unless interpreted as technical documents. Similar advanced knowledge appears in Egyptian, Sumerian, and Mayan texts. Most intriguing are ancient accounts of energy generation and transmission that parallel modern developments in zero-point energy and wireless power. The manna machine, described in Hebrew texts, bears striking similarities to bioreactors. Ancient Egyptian light bulbs, depicted in relief, suggest electrical knowledge. If these accounts contain even partial truth, the technological implications are staggering. We may be reinventing technologies that existed thousands of years ago, rather than pioneering entirely new capabilities. Our notion of technological progress may require fundamental reconsideration. Beyond technology, the philosophical stakes are equally profound. Modern civilization operates on the assumption of exceptionalism, that we represent the pinnacle of human achievement. If advanced societies rose and fell before us, this comforting narrative collapses, forcing us to confront our potential impermanence. This recognition carries psychological weight. Humans naturally resist evidence suggesting our achievements might be temporary or cyclical rather than permanent and progressive. The possibility that advanced civilizations were nearly erased from history challenges our deepest assumptions about human destiny. Dr. Maria Carmela Lico, archaeological psychologist, notes, "The resistance to evidence suggesting previous advanced civilizations reflects our cognitive dissonance. We've constructed narratives of continuous progress that provide psychological security. Evidence of collapsed advanced societies threatens that security. The environmental stakes compound this discomfort. If previous societies collapsed partially due to their own actions, deforestation, resource depletion, climate modification, we face the disturbing possibility that we're repeating the same patterns with exponentially greater technological capacity and population pressure. Recent paleoclimatic research suggests human-induced environmental changes began not with the Industrial Revolution, but thousands of years earlier. Evidence of anthropogenic deforestation, soil depletion, and localized climate effects appears in ice cores, lake sediments, and archaeological sites dating back millennia. This raises a chilling question. Could previous civilizations have contributed to the climate instability that ultimately destroyed them? If so, are we accelerating toward a similar fate, but with billions more people vulnerable to displacement, resource scarcity, and societal collapse? The geological stakes intensify when we examine Earth's cosmic vulnerability. The Younger Dryas impact hypothesis suggests a cometary fragment approximately 4 kilometers wide, striking Earth's ice sheets, triggered catastrophic climate change and flooding. Today, we track less than half of potentially hazardous near-Earth objects. NASA estimates approximately 25,000 near-Earth asteroids, large enough to cause regional devastation, exist in our solar system, with thousands remaining undiscovered. The cosmic threat that may have ended previous civilizations remains largely unaddressed despite our technological capacity to detect and potentially deflect these objects. Perhaps most consequential are the implications for scientific inquiry itself. If evidence for advanced prehistoric civilizations has been systematically misinterpreted or dismissed because it contradicts established paradigms, what does this reveal about the limitations of our scientific institutions? Thomas Kuhn's concept of paradigm shifts suggests scientific revolutions occur when anomalous evidence accumulates beyond the capacity of existing frameworks to explain it. The contradictions and out-of-place artifacts we've examined may represent precisely such anomalies, signaling an impending paradigm shift in archaeology and history. Dr. Robert Schoch, who redated the Sphinx based on water erosion patterns, observes, "Science progresses when we honestly confront evidence that doesn't fit our theories, rather than ignoring or explaining it away." The evidence for catastrophic events and advanced prehistoric knowledge has reached that critical threshold. The institutional stakes are significant. Academic careers, research funding, and publishing opportunities remain largely controlled by those invested in conventional chronologies. Researchers presenting evidence for advanced prehistoric civilizations often face professional ostracism, despite following rigorous methodologies. This resistance has historical precedent. When Alfred Wegener proposed continental drift in 1912, his theory was rejected for decades despite compelling evidence. Similarly, the impact hypothesis for dinosaur extinction faced ridicule before becoming scientific consensus. Paradigm shifts rarely occur without institutional resistance. As new technologies enable investigation of previously inaccessible underwater sites, this resistance faces unprecedented challenges. Remote sensing, autonomous underwater vehicles, and advanced dating methods are revealing evidence increasingly difficult to dismiss within conventional frameworks. The archaeological community now stands at a crossroads similar to physics in the early 20th century, when quantum mechanics challenged classical understanding. The accumulating evidence for catastrophic flooding events and advanced prehistoric knowledge may force a comparable scientific revolution in our understanding of human history. Recent discoveries have accelerated this process. In 2017, researchers documented evidence of human occupation in North America dating to 130,000 years ago, more than 100,000 years earlier than conventional models allowed. This single finding requires rewriting entire chapters of archaeological textbooks. Similarly, the discovery of Göbekli Tepe forced recognition that monumental architecture predated agriculture by thousands of years, the opposite of what conventional models predicted. Each such discovery erodes confidence in established chronologies and opens space for reconsidering evidence previously dismissed. The most significant recent development involves classified underwater discoveries that have not yet entered public scientific discourse. Multiple researchers with security clearances have described extensive underwater structures documented by military sonar systems but restricted from scientific publication. These allegedly include geometric formations off Cuba's coast at depths of 700 meters, extensive architectural complexes in the eastern Mediterranean predating conventional chronologies by thousands of years, and anomalous structures near Antarctica that challenge all existing models of human migration and development. While unverifiable through public sources, these claims align with declassified information about military underwater mapping capabilities far exceeding publicly available technology. The strategic significance of such discoveries, potentially rewriting human history, explains their classified status within national security frameworks. As we approach the climax of our investigation, the stakes have never been higher. If evidence continues mounting for advanced prehistoric civilizations destroyed by catastrophic flooding, we face a fundamental choice: adapt our understanding of human history to accommodate this evidence, or continue dismissing data that contradicts established narratives. The implications extend beyond academic debate to our very survival. If previous advanced societies were vulnerable to cosmic impacts, rapid climate change, and catastrophic flooding, our current civilization, despite its technological capabilities, may be equally vulnerable unless we learn from their apparent fate. In our next segment, we'll examine the most compelling evidence yet: recently discovered underwater structures that appear to display technological capabilities supposedly impossible for their age. These findings may force us to completely reconsider the timeline of human civilization and our vulnerability to catastrophic change. What we're about to explore challenges everything we thought we knew about human history and may hold the key to understanding our own precarious future in a world where the waters could rise again. Chapter 8: The Competing Explanations. After examining extensive evidence for catastrophic flooding approximately 12,000 years ago, we must consider the competing explanations for what actually occurred. Three major theories have emerged, each with supporting evidence and significant implications for our understanding of human history. The first, and most conventional, is the gradual meltwater pulse theory. This proposes that as the last ice age ended, warming temperatures caused ice sheets to melt steadily over thousands of years, gradually raising sea levels worldwide by approximately 120 meters between 20,000 and 7,000 years ago. This model, long the consensus view in geology, suggests sea levels rose at rates averaging 1 to 2 centimeters per year, slow enough for human communities to adapt by simply moving inland as coastlines retreated. Under this scenario, no sudden catastrophic flooding would have occurred. Supporting this theory is the generally smooth curve of sea level rise visible in most global reconstructions. Coral reef growth patterns and coastal sediment deposits in many regions show gradual transitions from terrestrial to marine environments, consistent with steady inundation rather than sudden flooding. Dr. Richard Fairbanks of Columbia University argues, the sedimentary record predominantly supports gradual sea level rise. While there were periods of acceleration, particularly during meltwater pulse, running around 14,000 years ago, these still occurred over centuries rather than weeks or months. This conventional view accounts for the widespread distribution of flood myths by suggesting they represent cultural memories of gradually rising waters, exaggerated over generations of oral transmission into sudden catastrophes. The universality of these stories reflects the universal experience of post-glacial sea level rise. However, this theory struggles to explain several key observations: the abrupt climate reversal of the Younger Dryas period, the sudden appearance of sophisticated architecture immediately afterward, and sedimentary evidence suggesting rapid rather than gradual inundation in many coastal regions worldwide. The second major explanation is the glacial lake outburst theory. This proposes that enormous lakes formed by melting ice sheets were periodically released when natural ice dams failed, causing devastating but regional flooding events that could have been preserved in cultural memory. During the last ice age, massive ice sheets created natural dams containing enormous volumes of meltwater. The largest, Lake Agassiz in North America, contained more water than all modern Great Lakes combined. When its ice dam failed around 12,900 years ago, it released catastrophic flooding. Geological evidence for these outburst floods is compelling. The channeled scablands of Washington state show unmistakable evidence of massive flooding when Lake Missoula repeatedly broke through ice dams, sending walls of water hundreds of feet high scouring across the landscape at speeds exceeding 80 miles per hour. Similar evidence exists worldwide. The English Channel shows features consistent with catastrophic flooding when a glacial lake in the North Sea breached its natural dam. The Black Sea flooding event approximately 7,600 years ago likely represents another such outburst when Mediterranean waters breached the Bosporus. Dr. Paul Carling, professor of geomorphology at the University of Southampton, notes, "These glacial lake outbursts represent some of the most energetic geological events in Earth's recent history. They could generate flood waves capable of traveling hundreds of miles inland and would have been utterly devastating to any human settlements in their path." This theory better explains the catastrophic nature of flood myths while remaining within conventional geological frameworks. It accounts for evidence of sudden inundation in specific regions while acknowledging that global sea level rise occurred more gradually over millennia. However, the glacial lake outburst theory has difficulty explaining the global synchronicity of flood myths, the Younger Dryas climate reversal, and evidence for cosmic impact events coinciding with this period. These elements suggest a more extensive catastrophe than regional flooding alone. The third and most controversial explanation is the cosmic impact flood theory. This proposes that approximately 12,800 years ago, Earth encountered fragments of a disintegrating comet, triggering multiple airbursts and impacts that had devastating consequences for climate, ice sheets, and human societies. According to this theory, comet fragments striking ocean basins would have generated massive tsunamis hundreds of feet high, while impacts on the North American ice sheet would have instantly melted thousands of cubic kilometers of ice, causing both immediate flooding and accelerating sea level rise. Supporting this theory is the Younger Dryas impact hypothesis, which has gained substantial evidence in recent decades. A distinct layer of unusual materials, including platinum, nanodiamonds, magnetic spherules, and carbon spherules, has been documented precisely at the Younger Dryas boundary across at least 4 continents. These materials display characteristics consistent with cosmic impact events rather than terrestrial processes. The platinum anomaly shows the same signature as no meteorites. The nanodiamonds form under the extreme pressures and temperatures associated with cosmic impacts. The spherules contain exotic materials rare on Earth's surface. Dr. James Kennett, professor emeritus at UC Santa Barbara, explains, "The evidence for a major cosmic impact event at the Younger Dryas boundary has become overwhelming. We have documentation across at least 4 continents of materials that can only reasonably be explained through extraterrestrial impact." This theory uniquely explains several puzzling aspects of this period: the sudden climate reversal caused by impact-generated atmospheric dust and disrupted ocean circulation, the simultaneous extinction of numerous large animal species, and the global distribution of flood myths with consistent astronomical associations. Furthermore, recent climate modeling suggests the Younger Dryas cooling cannot be adequately explained by glacial lake drainage alone, as previously thought. The sudden temperature drop, lasting over 1,200 years, appears to require additional forcing mechanisms consistent with the atmospheric effects of a cosmic impact. However, the cosmic impact flood theory remains controversial within mainstream geology. Critics argue that impact evidence is not uniformly distributed globally, that some claimed impact markers could have terrestrial explanations, and that the theory unnecessarily complicates established models of climate change. As we evaluate these competing explanations, we should consider that they may not be mutually exclusive. The evidence increasingly suggests a complex interplay of processes during this pivotal period in Earth's recent history, a period that appears to have profoundly shaped the development of human civilization. The gradual post-glacial sea level rise undoubtedly occurred over thousands of years. Within this longer process, glacial lake outbursts periodically released catastrophic regional flooding, and the evidence increasingly suggests these processes were punctuated by a cosmic impact event with global consequences around 12,800 years ago. Dr. Randall Carlson, geological and architectural historian, proposes, rather than choosing between competing theories, the evidence suggests we're looking at complementary processes operating at different scales and timeframes. The cosmic impact may have been the trigger that accelerated processes already underway. This integrated model helps explain the seeming contradictions in the evidence. It accounts for both gradual and catastrophic flooding features in the geological record. It explains the global distribution of flood myths while allowing for regional variations in how these events were experienced and remembered. Most significantly, this synthesis explains the curious timing of the Younger Dryas climate reversal and the subsequent emergence of sophisticated monument-building cultures worldwide. The cosmic impact may have disrupted existing societies while accelerating cultural and technological transfer between surviving populations. As we move deeper into the evidence, we'll explore remarkable new scientific discoveries that further illuminate what happened during this critical period. Discoveries that challenge our understanding of both Earth's recent history and humanity's role within it. Chapter 9. The New Scientific Revolution. Recent scientific breakthroughs have fundamentally transformed our understanding of what happened approximately 12,000 years ago. Advanced technologies, from satellite mapping to genetic analysis, from isotope dating to ground-penetrating radar, have revealed evidence previously inaccessible to researchers. Perhaps most significant is the revolution in underwater archaeology. Traditional excavation methods are largely impossible in deep water environments, but new technologies have opened these realms to systematic study. Remote-operated vehicles equipped with high-definition cameras can now document underwater structures with unprecedented precision. Synthetic aperture sonar, initially developed for military applications, can now create detailed 3D maps of underwater landscapes, revealing features invisible to conventional sonar. This technology has documented numerous anomalous structures on continental shelves worldwide that appear artificial rather than natural. Off India's Gulf of Cambay, extensive geometric patterns resembling street grids and foundation structures have been mapped at depths indicating they would have been above sea level before 7000 BC, thousands of years earlier than conventionally recognized urban civilization in the region. Similar discoveries have been documented in the Mediterranean, the Persian Gulf, and off Japan's coast. While mainstream archaeology has typically dismissed these as natural formations, advanced imaging technologies increasingly reveal details difficult to explain through geological processes alone. Dr. Sean Kingsley, marine archaeologist, acknowledges the technology has advanced faster than our interpretative frameworks. We're finding underwater anomalies that challenge conventional explanations, forcing us to reconsider what might have been lost beneath the rising seas. Complementing underwater discoveries is the revolution in space-based archaeology. Satellite imagery using multiple spectral bands can now reveal subsurface structures invisible to the naked eye. This technology has identified thousands of previously unknown archaeological sites worldwide, many dating to the immediate post-Younger Dryas period. More importantly, satellite mapping has documented extensive paleocanals, ancient river systems now buried beneath desert sands or ocean waters. These reveal that regions currently inhospitable, like the Sahara and Arabian Peninsula, featured extensive river networks and wetlands approximately 12,000 years ago. Sarah Parcock, professor of archaeology at the University of Alabama, explains, "We're mapping entire landscapes that existed before and immediately after the Younger Dryas period. These reveal environmental conditions far more conducive to advanced civilization than previously recognized. Fertile regions now buried beneath deserts and seas. Equally revolutionary are advances in genetic archaeology. Ancient DNA analysis has revealed population movements and bottlenecks coinciding precisely with the Younger Dryas boundary. Multiple human populations show evidence of severe reduction, followed by rapid expansion immediately after this period." A 2020 study published in Nature examined genetic diversity in populations worldwide and found evidence for a significant human population bottleneck between 12,900 and 11,600 years ago, followed by rapid diversification and migration. This pattern appears in multiple unrelated genetic lineages across continents. Dr. Johannes Krause, director of the Max Planck Institute for Evolutionary Anthropology, notes, "The genetic evidence suggests a major population disruption precisely during the Younger Dryas period. This aligns remarkably well with archaeological evidence for cultural discontinuities and the distribution of flood myths worldwide. Perhaps most surprising are discoveries from ice core science. Ice sheets contain annual layers that preserve atmospheric conditions over hundreds of thousands of years. Recent high-resolution analysis of ice cores from Greenland and Antarctica has revealed evidence for extraordinary events coinciding with the Younger Dryas boundary. Ice cores from Greenland show dramatic spikes in platinum, iridium, and osmium, elements typically rare in Earth's crust but common in meteorites, precisely at the Younger Dryas boundary layer. These anomalies match the composition of known cosmic impact residues and appear in both hemispheres simultaneously. More telling are discoveries of microtectites, tiny glass spherules formed under extreme heat within these same ice core layers. These require temperatures exceeding 2,000 degrees Celsius to form, temperatures achievable through cosmic impacts, but not through conventional terrestrial processes like volcanoes or lightning. Dr. Michel Patave of Harvard University, who documented the platinum anomaly in Greenland ice cores, concluded, "The abrupt platinum spike at the Younger Dryas boundary is best explained by a cosmic impact event. The composition and timing match perfectly with other impact indicators found worldwide. These scientific advances have revealed a series of apparent paradoxes that challenge conventional historical frameworks. These paradoxes don't invalidate established science, but suggest our models require significant expansion to account for newly discovered evidence. The first paradox involves the speed of climate change. Conventional climate models suggest major shifts should occur over centuries or millennia. Yet ice core data shows temperature changes of up to 15 degrees Celsius occurring within decades or even single years during the Younger Dryas transition. This paradoxical speed suggests trigger mechanisms or feedback loops not adequately captured in current climate models. The rapidity aligns better with catastrophic explanations like cosmic impact than with gradual processes alone, challenging fundamental assumptions about climate system stability. The second paradox concerns cultural sophistication. Conventional archaeology suggests humans were primitive hunter-gatherers before gradually developing agriculture. Yet sites like Göbekli Tepe reveal monumental architecture requiring advanced social organization and astronomical knowledge emerging fully formed immediately after the Younger Dryas period. This paradoxical cultural sophistication suggests either extraordinarily rapid development or, more plausibly, the survival and transfer of knowledge from earlier advanced societies disrupted by Younger Dryas events, societies whose physical evidence would now lie underwater on ancient coastlines. The third paradox involves biological extinctions. The end of the Pleistocene saw approximately 35 genera of large animals disappear from North America alone, species that had survived multiple previous glacial cycles. Why did these animals suddenly disappear during this particular climate transition? This extinction paradox aligns better with catastrophic events than gradual climate change. Many of these animals show evidence of abrupt disappearance rather than gradual population decline, with intact specimens found flash frozen in permafrost, preservation requiring extremely rapid freezing. Perhaps most significant is the memory paradox. How did isolated cultures worldwide preserve remarkably similar flood accounts if these events occurred gradually over centuries? The consistency of these narratives, often including specific astronomical details, suggests they memorialize actual catastrophic experiences rather than gradual changes. Dr. Elizabeth Wayland Barber, archaeologist and linguist, observes, human memory doesn't effectively preserve gradual changes across generations. The worldwide distribution of detailed, similar flood accounts strongly suggests these cultures experienced sudden, catastrophic events traumatic enough to enter permanent cultural memory. As we integrate these scientific discoveries and confront these paradoxes, a new understanding emerges, one that bridges the gap between ancient accounts and modern science, between gradual processes and catastrophic events, between conventional history and the anomalous evidence previously dismissed. This new synthesis suggests Earth experienced a complex sequence of events approximately 12,800 years ago. Cosmic impact fragments triggering climate disruption, accelerated melting, and catastrophic flooding in certain regions, all superimposed on the longer-term process of post-glacial sea level rise. The implications transform our understanding of both human vulnerability and resilience. If advanced societies existed before these events and were largely destroyed, with knowledge partially preserved and transmitted by survivors, we gain crucial perspective on our own civilization's potential fragility. As we approach the final revelations of our investigation, we'll examine the most compelling evidence yet, recently declassified discoveries that suggest human technological development may have followed a far more complex path than the straightforward progression from primitive to advanced that dominates our historical narratives.
Chapter 10. The Hidden Truth Revealed. We've journeyed through geological evidence, ancient myths, archaeological anomalies, and cutting-edge science. Now we arrive at the central question. What really happened during the Great Flood approximately 12,000 years ago? And what does it mean for our understanding of human history? The evidence converges toward a conclusion both simpler and more profound than either conventional or alternative narratives alone have suggested. What emerges is not a choice between competing theories, but a synthesis that integrates multiple processes operating at different scales and time frames. Around 12,800 years ago, as Earth was warming from the last ice age, something extraordinary occurred. Multiple lines of evidence indicate our planet encountered fragments of a disintegrating comet. Not a single apocalyptic impact, but a series of airbursts and impacts across at least 4 continents. This cosmic event deposited a distinct layer of unusual materials now found at the Younger Dryas boundary worldwide. Platinum, nanodiamonds, magnetic spherules, and carbon spherules bearing the unmistakable signatures of extraterrestrial origin and extreme heating not explainable through normal terrestrial processes. The atmospheric effects were immediate and severe. Dust and soot from widespread wildfires blocked sunlight, triggering the sudden climate reversal known as the Younger Dryas, a return to near-glacial conditions that persisted for over 1,200 years before ending as abruptly as it began around 11,600 years ago. But the cosmic impact had even more direct consequences. Fragments striking the ocean would have generated massive tsunamis. walls of water hundreds of feet high washing miles inland across multiple continents. Coastal populations worldwide would have experienced these as sudden, devastating floods. Equally significant, fragments striking the North American ice sheet would have instantly vaporized thousands of cubic kilometers of ice. This not only contributed to tsunami generation but accelerated meltwater release into the oceans, temporarily increasing the rate of sea level rise beyond the gradual background pace. This sequence explains a crucial paradox in flood myths worldwide. They consistently describe both water falling from the sky and rising from below, precisely what populations would experience from the combined effects of tsunami waves and rising sea levels accelerated by rapid ice melt. The cosmically triggered floods were superimposed on the longer-term process of post-glacial sea level rise that had been underway for thousands of years. This explains why geological evidence shows both gradual inundation patterns and sudden flooding events. Both processes were operating simultaneously at different scales. Dr. James Kennett of UC Santa Barbara concludes, "The evidence increasingly suggests the Younger Dryas impact was real and had profound consequences. It represents a major inflection point in Earth's recent climate history and appears to correlate with significant cultural disruptions worldwide. The human consequences were profound. Coastal areas, the most desirable habitation zones with the richest resources, would have been devastated almost simultaneously across multiple continents. Populations would have experienced catastrophic displacement, with survivors forced to migrate inland. This mass displacement explains another archaeological paradox: the sudden appearance of sophisticated monumental architecture in multiple inland locations worldwide immediately after the Younger Dryas period ended. These structures weren't built by primitive people suddenly becoming advanced, but by displaced coastal populations re-establishing themselves in new territories. Göbekli Tepe in Turkey, with its sophisticated astronomical alignments and megalithic construction, appears to represent exactly such a cultural re-establishment. Carbon dated precisely to 9600 BC, immediately after the Younger Dryas period ended, it likely represents knowledge preserved through the catastrophe and re-implemented afterward. Similarly, we see a pattern of astronomical observatories and sophisticated construction techniques emerging almost simultaneously across multiple continents following the Younger Dryas period, suggesting knowledge preservation and transfer rather than multiple independent inventions of complex systems. The genetic evidence supports this scenario. DNA analysis reveals human population bottlenecks and subsequent expansions precisely during this time frame, with evidence for mass migrations and sudden population displacements affecting multiple unrelated human lineages across different geographic regions. This explains why flood myths appear in cultures worldwide with such similar specific details. They don't represent cultural diffusion of a single regional event, but rather cultural memories of a global phenomenon experienced by populations across multiple continents and preserved through oral tradition. The astronomical references in these flood myths, consistent descriptions of unusual celestial phenomena preceding the floods, further support the cosmic impact scenario. They represent actual observations of comet fragments entering Earth's atmosphere, preserved in cultural memory and eventually recorded in early texts. What emerges from this synthesis is a profound revision of human history. Advanced coastal societies likely existed before the Younger Dryas events, with sophisticated knowledge of astronomy, mathematics, and construction techniques. These societies were devastated by the combined effects of cosmic impact, climate disruption, and catastrophic flooding. Survivors from these societies, displaced inland, eventually re-established aspects of their knowledge in new locations, explaining the seemingly sudden appearance of sophisticated capabilities in supposedly primitive societies worldwide after the Younger Dryas period ended around 11,600 years ago. This scenario resolves the central paradox of advanced knowledge without precedent that has long puzzled archaeologists. The apparent gaps in technological development weren't gaps at all. They represent knowledge transferred from earlier societies whose physical evidence now lies submerged beneath hundreds of feet of water on ancient coastlines. Marine archaeologist Dr. Sean Kingsley observes, "We've been looking for the origins of civilization in all the wrong places. The evidence increasingly suggests the most advanced early societies developed along coastlines now submerged. We're literally missing the most important chapters of human development. The implications extend beyond archaeology to our understanding of human vulnerability and resilience. The Great Flood wasn't a single event, but a complex sequence of catastrophes: cosmic impact, climate disruption, and accelerated sea level rise that collectively reset the trajectory of human civilization. Yet humanity survived. Knowledge was preserved through oral tradition, encoded in myths, and eventually in written records. Displaced populations adapted to new environments, rebuilt their societies, and ultimately recovered much of what was lost, though perhaps not everything. The most profound revelation isn't that advanced societies were destroyed, but that human resilience enabled crucial knowledge to survive catastrophic disruption. The seeds of civilization weren't planted only once, but multiple times throughout human history, with each iteration building upon preserved knowledge from previous cycles. This understanding transforms our perception of both ancient texts and modern science. Many ancient accounts previously dismissed as mere myth contain accurate observations of real events, preserved through cultural memory. And modern science, by integrating these accounts with physical evidence, achieves a more complete understanding than either approach alone. As we face contemporary challenges including climate change, cosmic threats, and societal vulnerability, the lessons from the Great Flood take on renewed significance. We aren't the first advanced civilization to face existential threats, and our technological capabilities don't guarantee immunity from catastrophic disruption. Yet the same evidence that reveals our vulnerability also demonstrates our remarkable resilience. Through all the catastrophes of the past, humanity has preserved its most crucial knowledge, adapted to changing conditions, and rebuilt what was lost. This capacity for cultural memory and adaptation may be our most important evolutionary advantage. The Great Flood approximately 12,000 years ago wasn't just a catastrophe that ended an era of human development. It was also the catalyst for a new beginning, one that shaped everything that followed and continues to influence our world today. As our exploration of the Great Flood comes to a close, we're left not with absolute certainty, but with a more nuanced understanding of Earth's dynamic nature and humanity's place within its cycles. The evidence suggests we've underestimated both the volatility of our planet and the complexity of our own history. The flood events approximately 12,000 years ago represent a profound inflection point, a moment when cosmic, geological, and human factors converge to reset the trajectory of civilization. Yet this wasn't the end of human achievement, but rather a transition between cycles of development, with crucial knowledge preserved through the catastrophe. This perspective transforms how we view our own civilization. We aren't necessarily at the pinnacle of human achievement, but rather at one point in an ongoing cycle of advancement, disruption, and renewal that has characterized our species' journey for tens of thousands of years. Perhaps the most valuable insight is that our greatest strength lies not in our technological achievements, which remain vulnerable to disruption, but in our capacity for cultural memory, our ability to preserve and transmit crucial knowledge across generations, even through catastrophic transitions. As we face contemporary challenges including climate instability, resource limitations, and cosmic threats, the lessons from the Great Flood offer both warning and hope. They reveal our vulnerability to forces beyond our control while demonstrating our remarkable capacity to preserve what matters most through even the most severe disruptions. The ancient flood myths weren't mere stories, but vehicles for transmitting survival knowledge, ensuring future generations would recognize warning signs, preserve crucial information, and rebuild effectively after catastrophe. They represent perhaps the most successful information preservation system in human history. Today, we face the challenge of creating equally effective systems for preserving our most important knowledge through potential future disruptions. Our digital information systems, for all their capacity, lack the durability and simplicity of myths transmitted through oral tradition and eventually recorded in stone and clay. As we look to the stars and contemplate humanity's future, we should remember that our journey hasn't been a straight line of progress, but a series of cycles, periods of advancement, and flourishing interrupted by catastrophes that test our resilience and force adaptation. with each rebuilding incorporating lessons from the past. The waters rose before, and they may rise again. What will determine our fate isn't whether we face catastrophe, which seems inevitable on a long enough timeline, but whether we've developed the wisdom to prepare, the resilience to endure, and the capacity to preserve what matters most for those who will rebuild after us. If you found this journey into Earth's hidden past meaningful, consider subscribing for more explorations of history's greatest mysteries. Our next episode will examine what ancient astronomical knowledge reveals about cyclic catastrophes and what it might tell us about our future.